And suppose we have a real number k. So this symbol means belongs to the set of all real numbers. So that means k is a real number. And we have a vector A. Then we can multiply this vector by this scalar, by this real number. So k times A, this is another vector. So we just denote this by the Ka. Okay. And this guy, this K times A, has the same direction as A if the K is positive. So if K is bigger than 0, then the direction of this K times A is same as the direction of vector A. So if this scalar is positive, then this product has the same direction as the direction of the vector A. And if the A is less than 0, then the direction of Ka is opposite to the direction of vector A. And if the K is equal to 0, then K times A is just equal to 0 vector. And also, the magnitude of this product, okay, the magnitude of the K times A is equal to the absolute value of K times the magnitude of the vector A. You need to watch out for this absolute value around this K. Okay, so because the magnitude and length are always non-negative, so here you need to take the absolute value for K. For example, if we have the vector A like this, then 2A is a vector which has the 2 times the length of the vector A and has the same direction as the vector A. So you may have the 1 and then 2. Then this guy is 2 times A. And another case, okay, another special case for this scalar multiplication is when the K is equal to -1. Okay, in this case we have the K equal to 2, right? We have the 2 times the A. So when the K is equal to -1, then this K times A is equal to -A. And this is called the opposite of the vector A. So if the vector A like this, then you have the negative A. So this guy is called the opposite of vector A. Now let's talk about the addition of two vectors. Right now, suppose I have the 1/4, which is the vector A, and its magnitude is equal to 200 pounds. And another force, which is vector B, okay, the magnitude of the vector B is equal to 300 pounds. Now, I want to get the sum of the A and the B. So, let me write this on the whiteboard. We have the magnitude of A equal to 200 pounds, and the magnitude of the vector B equal to 300 pounds is the sum of the vector A plus vector B equal to 500 pounds. So actually, we cannot add the two vectors in the same way as we add the two real numbers. So you cannot just say, okay, you add this 200 and 300, then you get 500. Actually, 500, this is just scalar, right? It's not a vector. We have the direction, okay, not only the number. So to add the two vectors, we have to use a law. It's called the parallelogram law. Now let's go back to that fig. So actually, you may use these two vectors to form a parallelogram. And then the diagonal, okay, this vector diagonal is called the sum of this vector A and vector B, or called the resultant of the vector A and vector B. So this is how we add two vectors. We just use these two vectors as the two sides to form a parallelogram, and then the diagonal of this parallelogram is the sum of these two vectors. And you look at the fig 7.25, and you can see we can place this vector A here and place the vector B here so that their initial points coincide with each other, and in this way we can form a parallelogram. Then the diagonal is the sum of these two vectors. Actually, when we add the two vectors, this sum is commutative. So we can have the A plus B, okay, vector A plus vector B equal to vector B plus vector A. So this sum is commutative, okay. So now, in this parallelogram law, we can also get the sum in such a way. So first, you get the vector A, and then you position the initial point of the vector B at the terminal point of the vector A. And then the vector which has the initial point of the vector A as the initial point and the terminal point of the vector B as the terminal point is just the sum of this vector A and vector B.